Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf Yaakob and I am from Material Engineering. This is my presentation video about joining glass to metal. Even the future depletion of resources, the concept of eliminating the use of unnecessary material and using only necessary material in a suitable location is critical. The development of joining technique of various material is important. These similar material joint have found widespread acceptance in many kind of industries such as electronic industry. One of the example of this similar material joint is metal to glass joining. Glass metal seal are used in variety of application today, including vacuum insulation, glassing, electric discharge to vacuum solar collector, and in glass encapsulated diodes. As we can see, metal is a solid material with a good electrical and thermal conductivity that is typically hard, shiny, malleable, and fusible and ductile. While glass, a hard brittle substance that is typically transparent for the translucent and created by rapidly cooling and sand with soda and lime. It is used to make window drinking glass and other items. Glass to metal joining are traditionally formed by mechanical pressing. A metal surface against the glass near its glass transition temperature. Because the glass viscosely deform at temperature and in diffusion is fast, the process can produce relatively strong bonds. Many applications, however, necessitate bonding at lower temperature where the glass do not. The two process of metal to glass joint is anodizing joining and soldering joining. This is the example of joining of metal to glass based on the research glass copper joining by anodic bonding and soldering with technique. Solder done by Li Fang Hu, Hoyong Shi Zhu, and Ho Wang. Okay, for the anodizing joining, first, aluminum foil with a thickness of 20 mm was anodically bond to glass substrate at 400 degrees Celsius per 100 volt. The aluminum film and glass wafer were individually and ultrasonically cleaned in ethanol before bonding and then dry with hot air. The aligned wafer were attached to the bonding platform with the glass side connected to the cathode and aluminum film connected to the anode. When the bonding process was completed, the wafer in the bonding equipment were cooled to room temperature. For the soldering process, second, the glass aluminum copper was soldered to copper using SN9ZN filler alloy at various soldering temperature. Before soldering copper, surface were polished with silicon carbon paper to remove the outside film, then ultrasonically cleaned with acetone for 5 minutes. The heating platform was loaded with copper substrate, SN solder and metallized glass wafer. When the temperature reached a certain level, the soldering process was carried out in the open air. The solder joint was cooled to room temperature in the platform after soldering. The heating and cooling rate are set at 5 degrees Celsius per minute and 3 degrees Celsius per minute, respectively, to avoid heating the can in the glass. Okay, this is the process of soldering and anodizing of metal to glass. There are 4 parameters that of anodizing and soldering joining for glass and metal. This parameter needed to be constant and controlled. The first parameter is soldering time, the second parameter is soldering process, and the third parameter is the cooling rate, and the fourth parameter is heating rate. This parameter is needed to be constant and controlled to create a good joint of metal to glass joining. The current issue in glass to metal joining is the difference in physical properties and and undesirable metallurgical interactions such as a brittle intermetallic formation are the main challenges for joining this millimeter. This is also include the joining of metal to glass. Physical properties is different that cause problem include the melting point and elastic modulus, and in particular the coefficient of thermal expansion. Thermal residue stress in the joint will develop in coefficient of thermal expansion are mismatched when the joint is cooled at 2 room temperature. As a result, when the material is heated to join them, the metal expands more than the glass. After the joint has been formed, the temperature must be returned at 2 room temperature. The metal wish to contract more than the glass as a result of this cooling, but this is no longer possible due to the joint with the glass. As a result, residual stress will form at the joining. The application of metal to glass joint are mostly lamps, hermetic package in electronic device, and electrical insulated feed-through connector. Lightweight material, higher performance, and increased functionality are some of the drive for multi-material hybrid structure, as well as the need for the similar material joining. Selection criteria, modeling, and inspection testing of joint are the most common parameters that need to be taken in closely. For the recommendation, there are several recommendations in improving joining of dissimilar materials, such as determine the critical process, material mismatch situation, and main failure mechanic. There is a lack of standardization in the field of testing and characterization of the dissimilar material joint. There is currently no widely accepted material testing standard for the similar material joint. Therefore, creating the standard of joining is to a good improvement. That's all for me. Thank you.